On the 14th of January 2005, the European Space Agency's Huygens probe entered the history books by descending to the surface of Titan, Saturn's largest moon. This was humanity's first successful attempt to land a probe on another world in the outer solar system. It took approximately 2.5 hours to go through Titan's hazy atmosphere to the surface. Titan is bigger than Earth's moon and larger than even the planet Mercury. This mammoth moon is the only moon in the solar system with a substantial atmosphere, and it's the only world besides Earth that has standing bodies of liquid, including rivers, lakes, and seas, on its surface. When the Huygens probe was about to land on Titan, a series of parachutes opened to slow the probe down. At around 160 kilometers above the surface, the probe's scientific instruments were exposed to Titan's atmosphere and started to transmit data to the Cassini orbiter. Traveling at a speed of just 18 kilometers per hour, Huygens made a gentle landing on the surface of this alien moon. For landings on the Moon or Mars, mission scientists plotted out landing sites with meticulous care. Telescopes and orbiters scanned the ground, imaging dangerous terrain and safe zones, and flight engineers pored over their maps and planned accordingly. But Titan was a mystery. Aside from a brief pass by Voyager 1 in 1980, little was known about Saturn's largest moon. Voyager results indicated that Titan is more like Earth than any of the planets. The abundance of carbon components may make Titan a natural laboratory to study the most primitive organic chemical reactions that were present on Earth some 4 billion years ago. Huygens entered the atmosphere enclosed in a heat shield to protect it from the strain of entry. After it passed through a danger zone, it ejected the back cover and deployed its large parachute. Once stabilized, Huygens blew off its front heat shield, ready to start its science mission. Huygens immediately started analyzing and recording, snapping its first image as it drifted 89 miles, 143 kilometers, above Titan's surface. It sampled the atmosphere as it passed through, measuring electrical signals and cataloging its journey in detail. After about 15 minutes, Huygens ejected its main parachute and continued descending under a smaller chute. Mission engineers had planned this switchover to allow Huygens to explore the upper atmosphere first, then descend more quickly so it would still have battery life by the time it reached the ground if it survived. Huygens continued collecting and transmitting data as it descended more rapidly through Titan's haze and clouds, encountering some turbulence on the way. On its way down, Huygens sampled the gases circulating in Titan's atmosphere and confirmed they were mostly nitrogen and methane. More importantly, it measured the temperature, pressure, and abundance of gases from the atmosphere's top all the way to the ground, creating a one-dimensional map of Titan's skies. It revealed high levels of stratification, passing from one zone to another as it fell. One of Huygens' goals was to hunt for noble gases, such as argon. Noble gases are chemically disinclined to join with other elements to form compounds, so their abundances hint at long histories, stretching back to the availability of these gases at the birth of the solar system. Their presence helps scientists understand how Titan's atmosphere came to be, and, likewise, how other worlds like Earth might have attained similar thick atmospheres. Safely aground, Huygens continued its mission. It assiduously recorded image after image of its final resting place for 72 minutes after touchdown. In all, it sent back over 100 pictures of the same slice of terrain before Cassini and its link to Earth disappeared over Titan's horizon. A short time later, its batteries ran out, and the probe quietly shut down. Huygens appears to have landed on a surface resembling sand made of ice grains. Surface pictures showed a flat plain littered with pebbles as well as evidence of liquid acting on the terrain in the recent past. Subsequent data confirmed the existence of liquid hydrocarbon lakes in the polar regions of Titan. From the first images, Huygens forever changed scientists' understanding of Titan. Its pictures showed riverbeds, channels cut clearly into Titan's face. These rivers showed drainage networks similar to those found all over Earth, small channels feeding into larger rivers, which empty out into flat deltas. Bright highlands showed rough, jagged terrain. Steep river valleys and canyons indicated that Titan's rivers could be prone to flooding, and likewise showed signs of methane rain erosion. Other riverbeds hinted at gentler streams. Scientists think these are fed not by rainfall but from spring sapping, where liquid methane wells up through the ground. Closer up, Huygens took stock of its landing site. The probe touched down on a dark plain. While it saw no sign of current surface liquid, the region strongly resembled a dried lake bed or floodplain. Scattered around Huygens base were cobblestones, edges rounded as if shaped by flowing liquid. The stones are of a similar size, implying that the same current might have moved all of them, but scientists remain unsure whether this is the case. While Huygens' science mission lasted a fraction of Cassini's decade, its contributions were mammoth. It remains the only human-made craft to touch the face of any moon other than our own. Huygens quite literally scratched Titan's surface. And by opening up an entirely new world to researchers, it also jump-started a new generation of research, inviting questions by the thousands. Scientists then and now look to Huygens as the only eyewitness to an entire complex world, but studies are limited by the short time and tiny area the probe could explore. So far from the sun and under Titan's hazy skies, Huygens took its pictures in a twilight sort of lighting. At one point, its vision included a dewdrop that formed on the probe's exterior. While probably induced by Huygens itself and the heat from its landing, the single drop was nonetheless the first in situ sighting of liquid on a world other than Earth. Currently, scientists are still working on a new mission to explore Titan, and they are planning to use a specialized drone called the Dragonfly. The Dragonfly, which won't look like a little backyard drone, but more like a flying Mars rover, will spend 2.7 years making a couple of dozen short flights around Titan. Its ultimate goal is to create a total journey of around 108 miles, which is farther than all previous Mars rovers combined. Dragonfly is gunning for the Selk impact crater, where scientists believe all three crucial ingredients for life may once have met. There's evidence it once held liquid water, plus the organic molecules and energy in the form of sunlight found elsewhere on the surface. There's also hope that Titan's suspected subsurface ocean might come up high enough to interact with its other life-giving ingredients, which would open up the possibility for some kind of life below the towering sand dunes and methane rivers. Dragonfly is set to launch in 2024 and arrive at Titan in 2036, so our dreams of playing in an early Earth sandbox will have to wait a while longer. But when we do get to Titan, whatever we learn is going to give us game-changing insight into the origin of life as we know it. Until then, like this video and subscribe, cause we'll be keeping you updated. Thanks for watching.